Alright, so we continue our lecture. This is about point and interval estimation. So any estimation problem, right? We need to obtain both point estimate and interval estimate. So remember last class that I already mentioned to you what is point estimate, point estimator, and interval estimate. So point estimate is the value corresponding to the point estimator. So let's say mu equal to x bar equal to 1.28. So this is what we call as point estimator, and this is what we call as point estimate, right? So point estimate is the exact value in our estimation, right? So it's rarely happen in the real life to get the exact value as a point estimate. So normally when we do estimation of or any statistical inference, we will do an in term of interval estimate, right? In term of range, let's say from 1.01 until 1.52. So the value of 1.28 is the point estimate, and the value between 1.1 and 1.52 we call as an interval estimate or confidence interval. So this is another name for point interval estimate. Interval estimate, right? Or confidence intervals. So the point estimate is our best guess that our parameter for our parameter, while the interval estimate give the measure accuracy of that point estimate by proving an interval that contain plausible values. So our estimation will be lies between 1.01 and 1.52. So this is the exact estimate lah. So now let's look at example. Suppose we want to know how much foreign tourists spend in Sarawak in a day. So we can ask all the tourists in the Sarawak, which is a population, right? But this is quite impossible to get the whole tourists to respond to our study. So for sure cannot. Instead, we ask a sample of tourists, right? Let's say we can ask 10 foreign tourists how much they spend in Sarawak, and then calculate the mean to be, let's say 200, right? So 200 is a statistic, right? So we should use x bar for 200, right? Statistics is a measure or summary measure taken from sample, right? Parameter is a summary measure taken from population, right? So so does this mean population mean is equal to 200 as well? Dia tanya sini kan soalannya. So answer is 200 is only estimate of the population mean, right? So we can now we can never know the actual value of mean. So means that the mu is unknown. So kita tak tahu the value of population mean, right? What we know is the sample mean. So then that's come the theory of point estimate lah. So we need to estimate the value of monthly or the total spending of the tourists in Sarawak to the population. So we need to do a good estimate. So to do the good estimate, we need to estimate lah using a confidence interval or interval estimation. So in interval estimation, right, it require some value, right, of the parameter we call as 1 minus alpha multiplied with 100%, which is this is the value that we confidence our estimate is correct, right? So we want to know what is the total spending for the tourists, for the whole population, with 95% correct or 99% correct. So always reserve some error for our estimation. So we are not, in statistics, we are not saying that our estimation is perfect, right? There is a possible error or possible incorrect estimation. So how to prevent the value that we estimate to be lies on the incorrect estimate? So we need to minimize our error. So let's say if you want to do estimation, let's say I want to find 95% of confidence interval. It means that we want to find the value of the estimation, let's say in a normal distribution curve. 95% of the estimation would lies under our estimate lah. So this is a 95%. Another 5% will be called as error, means that incorrect estimate. So this is going to be 2.5% to the left, another 2.5% to the right. Right? So usually we are using 90%, 95%, and 99% for our estimation. Right? So there is not really simple, this simple lah. So if you want to find what is the possible error that might be occur in our estimation, we need to calculate the probability of type 1 error. So there is a probability of type 1 error. So type 1 error means that, so in statistics there are 4 regions. So let's say this is observed, this is predicted. So this is a common statistical measure. This is if you are dealing with machine learning, this is what we call as a confusion matrix. So if you have gone through to machine learning lah, or artificial intelligence, right? So you will dealing with the confusion matrix to know that, let's say this is a true, false, false. If we predicted or we estimate the value is to be true and the observed value is also true, then this is a true positive. If the estimation is false and the observed is also false, this is what we call as true negative. So this is a true value lah, which is our estimation is correct. If our predicted is true and the observed is false, means this is what we call as type 1 error. If the predicted is false and the observed is true, this is what we call as type 2 error, which is our estimation is going to be a slightly dispersed from our estimation lah, which is not correct. So this is a not correct estimation. This is also not a correct estimation. Right, so now let's look at guideline of using T or Z distribution. As I mentioned in previous class, in previous lecture, Z distribution is a standard normal distribution. Right? Why? It came from a normal population. So we want to estimate the value by using a standard normal distribution. T distribution is also came from a normal population. So that's why the distribution is also look like normal distribution. The only difference is when the population is very small. The number of sample size in the population is very small, so we need to do some adjustment. With the adjustment is by using a degree of freedom. Degree of freedom. So degree of freedom will modify the number of sample size by n minus 1, by 1 lah. So that's why it is a t distribution. So kalau kita tengok dekat sini, when we have a small sample which is n less than 30, this one I already showed to you yesterday kan. So this is based on central limit theorem. When you have a large sample, so the distribution is approximately to normal distribution. Kita nampak kan yesterday I dah tunjuk dekat you, I demonstrate when the sample size is 30, the histogram nampak macam normal tapi dia belum fully normal. When you increase the sample size to 100 to 500 to 1000, so dia akan nampak the shape or distribution to be bell shape, right? So that's why when you have a small sample which is n less than 30, this is just a guideline, but this is not always true, but most of the book use 30 as a benchmark. So we will follow all the books, right? Less than 30, we will use t distribution. If the sample size is more than or equal to 30, we will use z distribution, right? Z distribution, symbol is z. T distribution, symbol is t, but with some modification, which is degree of freedom, right? So now let's look at confidence interval for a mean, right? So the point estimate, right, for the population mean is given by the sample mean, x bar. So x bar for known variance and unknown variance. So dekat sini, if you know the population variance, right? So I make it clear lah dekat sini. Let's say population variance, right? Population variance known, unknown. So if you know the population variance, then you will use z distribution. If the population variance is unknown, so we will look into two conditions. Whether the sample size is less than 30 or sample size is more than or equal to 30. Right? When the sample size is less than 30, we will use t distribution. Or sample size is more than 30, we will use z distribution. So this is more clear diagram, right? So most of the practical situation, right, if you want to estimate, right, maybe we don't really know the characteristics and the dispersion or spread of the whole population, right? Or maybe we know. If you have a very concrete sample size sampling, you are using a randomized sampling techniques, maybe you will know population value, the summary measure of population. So we will use that distribution. It doesn't care whether the sample size, this is for n more than or equal to 30 and n less than 30, right? If you know the population variance, then we can use z distribution for both cases, either the sample size more than 30 or less than 30. If the population variance is unknown, there are two conditions, whether n less than 30 or more than 30. If less than 30, we will use t distribution. If more than 30, we will use z distribution. Right? So now let's look at this one. The formula for z distribution is x bar plus minus. Why there is a plus minus? Because in a confidence interval or interval estimation, There are two parts. So the first part we call as a lower confidence limit. The upper part we call as upper confidence limit. So this is a lower confidence limit and this is a upper confidence limit. So our estimation will be lies between lower and upper confidence limit. Right. So Z distribution, we need to multiply with Z alpha divided by 2. So if we are considering two-sided distribution lah, means remember on a normal distribution we have two-sided kan, so either positive side or negative side, right? So this is a negative side, this is a positive side, so we don't care this value, right? So we want to know this estimate on the middle. So this is what we call as two-sided. If we want to find a one single-sided, right? Let's say we want to find the value to the right. So this is only the value yang kita nak estimate to the right. So this is what we call a single or one side, right? Ataupun kita nak cari to the left only, right? To the left only. So this is also one-sided. So if we want to consider for two-sided, we need to use Z alpha divided by 2 because there are two-sided that we reserve for error. So this is the rejection region. So later on kita akan discuss more detail on rejection region and acceptance region. This is a rejection region. This is acceptance region. Same goes to this one lah. This is a rejection. This is a acceptance region. This is a rejection region. Sama juga. Right? So, if you want to consider for single-sided, so we just put Z alpha. Right? So, clear this one? Two-sided and single-sided. So, for unknown variance, when the sample size is very small, then we will use T distribution. This is for n less than 30. T distribution for two-sided alpha divided by 2 with degree of freedom. So degree of freedom is normally we dalam banyak buku ada tulis V, ada tulis DV, DF, mana-mana suka hatilah. So as long as we understand what is the definition of degree of freedom. Degree of freedom is n minus 1, means sample size minus 1. So when n is more than or equal to 30, so we can use another formula, x bar plus minus, we're not going to use T anymore, we're going to use Z alpha divided by 2 S divided by square root of n. This is where the sample size is more than 30. Why we are using this one? Because it's based on central limit theorem. When the sample size is increased or large enough, then the distribution is normally or approximately to normal distribution. So I hope you understand this one. Very simple and slowly I explain to you. Right. So now let's look at the next step. So this is the confidence interval from a SPSS output, right? So in SPSS, right, this is for a single one sample t-test. So this is a one sample t-test. So of course they are using t distribution lah, because it's t-test. So they will give you two tables. First table is one sample statistics, which is it will summarize to you the sample size, mean, standard deviation, and standard error of the mean. Standard error of the mean is standard deviation divided by square root of n. right? So you will get 1.37517. So you need to know how to calculate this value, right? So sometime in your final exam or test, I will hide this value. I will ask you to calculate this value, right? You need to know the formula, right? Another table is one sample t-test. So let's say the test value is 30, right? Means that we want to know whether it's uh, exactly equal to 30 or not equal to 30. So we will use t distribution, one sample t distribution. So this is a t distribution, a t value, t statistics, and this is a degree of freedom. Mana dapat 29 ni? 30 tolak 1. Remember, degree of freedom is n minus 1. This is a significant test, p-value. Nanti kita akan tengok p-value, but p-value is, I'm not going to emphasize on p-value. We will look into confidence interval. So the mean difference means that there is a difference. So let's say 30.79 tolak dengan the value of 30. The value of 30, then we will get 0.7916. Oh, dia dekat sini dah. Right. So this is the value of different, mean different. Right. And then this is the confidence interval of the difference. Confidence interval of the difference is D difference plus minus. So here we are using T distribution because we are dealing with the T distribution. Alpha divided by 2, n minus 1, standard error. Right. Right. So this is the formula for confidence interval of different, mean different. So if you want to calculate a confidence interval for mean, so we will use Z distribution. Why? Because our sample size is 30. Right? Remember, when n is more than or equal to 30, then we will use Z distribution. Please pay more attention on this. Right? So we will get the confidence interval. Right? So this is a confidence interval for mean difference. So nanti kita akan tengok example. So now let's look at example number 9. So the average zinc concentration recovered from a sample measurement taken from 36 different locations in a river found to be 2.6 gram milliliter. So we have n equal to 36 and mean is equal to 2.6. Dia kata kat sini find 95% confidence interval. Right? So our alpha is equal to 0.05. Mana dapat benda ni? So 100 minus 95%. So equal to 5%. So our alpha is 5, 0.05. So alpha is expressed in terms of probability value lah. Right? So assume that, dekat sini, okay. Assume that the population standard deviation is 0.3. So based on the confidence interval obtained, can we conclude that the mean zinc concentration river is more than 2.0 milliliter? Can we conclude our mean zinc, so this is what we want to find lah, is more than 2.0. We want to know this value, right? So by using this, we can calculate confidence interval of the mean. Confidence interval of mean. So x bar plus minus z alpha divided by 2 and square root sigma divided by square root of n. Sebab apa sigma divided by square root of n? Sebab dekat sini dia kata population standard deviation is 0.3, means that the population standard deviation is known. Remember chart yang I buat kat atas ni, mana tu? This one. Population variance known, Z distribution. We don't care whether the sample size is less than 30 or more than 30, right? So then we input into the calculation. X bar is 2.6 plus minus Z. Since our alpha is 0.05, so 0.05 divided by 2, because this is a two-sided distribution. And population standard deviation is 0.3 divided by square root of 36. So now 2.6 plus minus Z alpha divided by 2 is Z 0.025. Betul? Alpha 0.05 divided by 2, 0.025, right? So now, let's look at into the statistical table. Table number 4. Table number 4. So, dia kata dekat sini, this is the value of alpha. So, this is the alpha value dekat sini. So, 0.025 is somewhere here. This is the value 0.025, which is 1.96. So, we input the value 1.96 over here, multiply with 0.3 divided by 6. So remember, tadi saya cakap, dalam confidence interval, we have a lower confidence limit and upper confidence limit. Right, upper confidence limit. So, lower confidence limit is 2.6 minus 1.96 multiplied with 0.3 divided by 6. Upper confidence limit is 2.6 plus 1.96 multiplied with 0.3 divided by 6. So then we will get the value lah. The value yang dia bagi dekat sini. So this is the value 2.502 is our lower confidence limit, and 2.698 is upper confidence limit. Right? So we can say that we have 95% confidence that the mean zinc will lies between 2.502 gram per milliliter and 2.698 gram per milliliter. So the question here, can we conclude that mean zinc is more than 2.0? Yes lah. We can conclude that mean zinc is more than 2.0 because the estimation is between 2.5 and 2.6. Boleh faham ah? Right. So let's look at the example number 10. Example number 10, 12. Kita ada banyak example lah. Okay, sampai 13 saja kita stop. Right. Example number 10. So the amount spent for grocery for 25 housewives, so N equal to 25, were taken randomly. Based on the information given, calculate the confidence interval of mean. So bukan mean different, of mean of the amount spent for groceries of housewife. So we know that mean is equal to X bar is equal to 210. Standard deviation is equal to 11.4. So we need to understand, is this sample standard deviation or population standard deviation? We want to justify this one because we want to choose whether we want to use Z distribution or T distribution. So since dia kata dekat sini, amount spent for 25 housewife, taken randomly. Means that this 25 is a sample. You take a sample housewife, and this is the this is the summary information for 25 housewife. This is based on statistical SPSS output, right? So since the sample size is less than 30, then the population variance is unknown. We don't know the population variance. So we need to use T distribution. So X bar plus minus T alpha divided by 2 n minus 1 S divided by square root of n. So this is the formula that we want to consider. And dia tak bagi tahu kat sini berapa persen confidence that you want to consider. So if we don't tell dalam soalan, so we will assume a 95% confidence interval. So now our mean is equal to 210.35, S is equal to 11.44, N is equal to 25, and alpha is equal to 0.05. Yeah, I already explained why we get to 0.05, because 100% minus 95% of the confidence is equal to 5%. So we express the alpha in terms of probability value, 0.05. So now X bar is 210.35 plus minus T 0.05 divided by 2, and minus 1 is 25 minus 1 is 24. S is equal to 11.44 divided by square root of 25. Right? So I tulis sebelah ni. So 210.35 plus minus T alpha divided by 2 is T 0.025 with the degree of freedom 24. So now, let's look at statistical table. So we no longer use table number 4 because this is a normal distribution. We need to use table number 7, I think. Yeah, table number 7, which is T distribution. Right? So T distribution, table number 7. So remember previously I already explained to you, T distribution came from a normal distribution, right? With some adjustment of degree of freedom. Why? Because we have a very small sample size. So that's why if you look at this distribution, they look like normal distribution. It's a bell-shaped distribution. And the value that give to us is to the right distribution, to the right value, kan? Alpha dalam ni. Sama saja, cuma this value instead of Z dekat sini, ini adalah value T alpha divided by alpha and degree of freedom. So dia tak divide by 2 because this is a single-sided distribution. Apa yang kita nak cari dekat sini is two-sided distribution. So they're going to be like this lah. So two-sided. So this is 0.025. This is 0.025. So this is 95%. So this is the value yang kita nak cari. Lower confidence limit. This is upper confidence limit. So this is the value that we want to estimate. Right. So now, since alpha 0.025 dekat sini, right? I tak boleh highlight dekat sini. 0.25. This is alpha value. Nampak tak? On the first row, on the top row, is the value of alpha 0.025. V here is degree of freedom. So dia beritahu dekat atas ni, V is the degree of freedom. Right? So degree of freedom, our degree of freedom is 24. 24 kita cari kat bawah lah, 24. So this is the value of 24 and alpha 0.025. So then the value of T alpha 0.025 with the degree of freedom 24 is 2.064. So this one is 2.064. So we need to input into the formula lah. So 2.064 multiply with 11.44 divided by 5. So our lower confidence interval and upper confidence interval. Input into the calculator, right? Let's say I use this one. 210.35 minus dalam kurungan 2.064 multiply with 11.44 and divide by 5. Tutup kurungan. So we will get 205.63 lah, 63, right, for the lower confidence interval. So upper confidence interval, we need to change the value of sign, negative sign to plus sign, right? So 215.07, 215.07. So we can say that we have 95% confidence that the mean amount spent of 25 housewife is between RM 205.63 and RM 215.07, right? So this is how we interpret the value of confidence interval. Okay. Alright. So now let's look at example number 11. So example number 11 actually benda yang sama saja. So manager of hotel state that the mean gas bill during weekend are 700 or less. So then dia kata gas bill is less than RM 700, less than or equal to. So accounting staff noticed that total charge for gas has been increased recently. Right, a sample weekend gas was taken to test the manager claim. So dia nak buktikan kepada manager dia, you're wrong, right? Bukan less than 700, but maybe more or maybe less. We don't know. We need to calculate that. So the SPSS output is given. So we have n is equal to 20, mean is 705, standard deviation is 114, and standard error of the mean is 25.61, right? So we need to calculate the 95% confidence interval for mean weekend gas bill. So we look into n is equal to 20. This is very small sample size. And the standard deviation is the sample standard deviation. We don't know the population standard deviation because we only calculate the standard deviation from 20 samples. So we're going to use t distribution as well. So x bar plus minus t alpha divided by 2 with degree of freedom s divided by square root of n. So we just plug in the value lah. 705.80 plus minus t alpha 0.05 divided by 2 with 20 minus 1, and this is 114.56949 divided by square root of 20, right? So t 0.025 with degree of freedom 19 should be 0.025 19 is 2.0 2.093. 2.093. Betul? Double check. Yes. Right? So you just plug in the value and we will get uh, the the confidence interval for the mean lah. Right? So next, ini you calculate sendiri ya. So we don't have much time. So next is we want to find 95% confidence interval for mean difference. Mean difference, so D plus minus T alpha divided by 2 with degree of freedom S divided by square root of N. So D is 705.80, which is our mean, minus the claim mean. Right? Claim is 700, right? So the claim tadi berapa? 700 kan? Right? 700. So this one should be 5.80. So you input the value 5.80 plus minus. This is still the same value 2.093 multiply with 114.56941 divided by square root of 20. But actually this value, kita tengok dekat sini, 100, sorry, I letak 114.56941 divided by square root of, oops, square root of 20. It should be 25.61. So sama juga dekat atas ni. Right? So basically, if they give us the standard error of the mean, you just multiply with the value yang dia bagilah. So this is 25.61852. Right? So you calculate the value of lower confidence interval and upper confidence interval. So we can conclude that 95% of the mean difference, we have 95% confidence, so for the mean difference is between apa-apa. Right? Boleh eh? So for example number 12 and 13, kita tengok later lah. Right? But you also can do it by yourself. This is very simple. So 16 workers, dekat sini dia bagi, okay, I tunjuk lah. 16 workers, the sample size is very small and it's less than 30, right? So they give us the value of summation of x and summation of x square. So from here you can find the value of x bar and s, right? By using the formula lah. I remember chapter number 2, we already learned how to calculate mean and standard deviation from the sample. So since this is a very small, population variance is unknown, so we can use x bar plus minus t alpha divided by 2 with degree of freedom s divided by square root of n. Okay. Oh, sorry. This is for this one. Right. For this one, point estimate means that you need to find mean and standard deviation lah. Right. For example number 13, nanti kita akan revisit balik example number 13 ni. I want to show you how to use SPSS. So benda yang sama juga, we have a random sample n equal to 10. We don't have the population variance, so population variance is unknown. Right, population variance is unknown. So find the point estimate, mean and s square. Right. And this one sama juga dengan atas tadi. Confidence interval of the mean, x bar plus minus t alpha divided by 2 with degree of freedom s divided by square root of n. Right. So most of the example dekat sini menggunakan t distribution lah. Except the first example yang kita nampak ni menggunakan z distribution. Right. For the last one, confidence interval it obtained, can you conclude the mean calories carb is less than 100? So you need to base on this one lah. Tengok dia punya range dia tu, right? Ada soalan tak before we end our session? So next class we will look into confidence interval for different domains. So this is quite big as topic jugalah, right? So next class I will demonstrate how to use SPSS. We will revisit example number 12 and example number 13. Any question?
Sir,
Yes.
soalan 12 ni, kalau kita cari dia punya variance, maknanya dia punya variance tu disebut lah ke unknown.
No. Variance dekat sini adalah sample variance. Right? So it based on sample. So the population variance still unknown. So this variance kat sini adalah sample variance lah. Macam mana cari sample variance? Summation of x square minus summation of x square divided by n minus 1, everything divided by n minus 1. So you will get sample variance. Okay? Lain soalan? No question? So if you don't have any question, then we end here lah. Alright. Okay, Assalamualaikum.